We start today our class. It's about the circular motion. The second lecture. First lecture we discussed about the. I make quick review, as we know. So the quick review. It's about three important things. What is the definition of the circular motion? ماذا يعني الحركة الدائرية? What it means? The circular motion means when the movement or the motion it takes path as a circle, so that means it is a circular motion. So that is the definition of the circular motion. The acceleration in the circular motion. Where is the acceleration direction in the circular motion? There is two types of acceleration in the circular motion, and also we can describe or we can determine the circle with two things, with its center and with its radius. So be careful about this information. There is two types of circular motion. One is the uniform. What is the mean of uniform? The other is non-uniform motion or ununiform motion. The uniform means constant. Which is constant? It is the speed. The other, the non-uniform motion, means there is no thing constant, all is variable, so that means the speed is, or the velocity, it changes with the speed. So today we start, and also from last lecture we know how you can find the angular position. That means why I discussed about these things, because now it's not linear in motion, so it's circular. It's motion, it moves in a circle. The circle depends on the radius, so the radius, so all thing it means with the angles, so it's changing with the angles. So the position is angular position, the velocity angular velocity, the acceleration angular acceleration. But in this section, and we know the circular motion is the one of the examples in the motion in two dimension. We just discussed about the velocity, we discussed about the speed, we discussed about the acceleration in linear and also in angular. So if we have a circle motion, so that means if I imagine it, it means there is an example of the motion in two dimension, in x and in y. When I have an object, for example, it is here in this point, for example, for point A, and it moves to point B, from B to C, from C to D. So what is the change? It's changing the angle. So as I draw here, but where is the velocity? Always the velocity, it is tangent to the path, so that is the velocity. It's here up, then here it's moving up, so it is in what? In x or in y. Where is it? Here, if I try to explain it, so it is in y, so that means in j. So k is equal to 0, I is equal to 0, because the motion in one dimension in this point, because there is no in x, just only in y. Then still till here, so y is equal to 0 and I in minus in quarter 3, and you can describe the point still it returned back to the same point. And from our title of this subject, the circular motion and the uniform circular motion, and we know there is two types of the motion in circle. There is two, one uniform, the other ununiform or non-uniform. So today we discussed about the motion as uniform. So what's the meaning of uniform? The uniform means there is something is constant. What is the thing is constant? It is the speed as a magnitude. So be careful. Here the uniform means something is constant. What is the variable it's constant? It is the speed. A speed as a magnitude. But which it gives this motion like a circuit, it is a velocity. So be careful about these 2 points. Speed as a magnitude is constant. Velocity as a direction, it is not constant, it will be changed. What is the example? The nice example for this, any motion moving from the start in circle. For example, the ceiling fan. When it starts moving, so it moves till the numbers that you fixed in it. So that means I fixed, or you fixed the speed in number 2 or 3 or 4 or 5 as you make it from the control point. That is the nice example for the circular motion. Then what is the acceleration? I want to know the acceleration. From chapter 2, we know the acceleration A is equal to delta V over delta T. That is as instantaneous. As an average, it is delta V also divided by delta T. For instantaneous, I can find it as derivative in each moment. But here I cannot make derivative. I can bring it as average acceleration from the V final and V initial. In chapter 2 we know it, the average acceleration, maybe it's positive, maybe it's negative, and it depends on the direction of the velocity. And the velocity as a factor, maybe it's with the same direction and it's positive, maybe in opposite direction and it is negative. If I wanted an instantaneous, so now mathematics. The instantaneous from the average, it is the limb appreciate to 0 of the average equal to the limb appreciate the time to 0 with delta V over delta T. So from this equation now, if I take the limb for each side, so how I can produce the or generate the motion from this equation? How I can generate? So I have 3 things. Number 1, with change the magnitude. What is the change of the magnitude? Means change the speed from the key of the fan or from the source of the things that you wanted to rotate or make force hard force, so it rotates more. So that means I change the speed. The speed is the time of the circle, how many times it cover in 1 second or 1 revolving. Then I change the magnitude, so I change the number. Number 2, I change the velocity. The velocity as a factor, it is direction. The third things, I change the 2, both the direction and the magnitude. So I can generate or I can produce the motion from the equation with 2 things. The other one is both. Number 1, change the speed as a magnitude. Number 2, change the velocity as a direction. Number 3, I can change both of it, the speed and the velocity, so I can generate or produce circular motion from the equation of the average acceleration. So Now, what is the, where is the acceleration? Or how I can find the acceleration in circular motion? For example, when I have 4 points, I take 4 points. First, there is many points here. So I take 4 points. 1, 2, 3, 4. So I take 4 points. And I choose the probability of the factors and see where is delta V and where is the acceleration. And I check it. So from the probabilities of the factors, so the factors can be shifted at any way. But you must be respect the important condition. Number 1, the direction. Number 2, the magnitude. So here, that is the velocity 1, that is a factor 1, that is a factor 2. So I put, as I drawing the factors, so I put my cross. That is the velocity 1 with 1 unit up, V1. Where is V2? It's in J hat. Number 2, minus, in minus I hat, so it's here. So where is the resultant factor? That means delta V. Delta V is the closed factor, head to head. Where is the resultant factor head? It is to the final. So where is the final? The final is 2. So that is delta V. So where is the acceleration? It is in the same direction of the change of the velocity in parallel. So that is for number 1. So where is the acceleration? So it is here. Number 2, 4.2. So now I finish this part. Now part 2. That is part 1. Same things. I put my cross. Where is V2? V2 in this point. I respected its direction and its magnitude. V3 in minus J hat. So that is V3, that is V2. So where is delta V? Head to head, the direction of the resultant to the final. So that is delta V. And the acceleration, parallel direction, parallel to the delta V. So that is the acceleration 2. Number 3, with the same things. Where is 3? In minus J hat. That is V3. V4 in where? In plus I hat. That is V4. Where is delta V? That's it. Head to head. Where is the head of the resultant to the final? So delta V. Where is the A? Point 4, with the same things, I put my cross. Where is V4? V4 in plus I hat. V1 in plus J hat. Where is the delta V? Head to head. The resultant, its head shows to the final factor. So that is delta V. Where is A? A is inside. So from this example, what you can see there is an acceleration. This acceleration always pointed to the center of the circle. So this acceleration pointed to the circle, it gives name as centripetal acceleration. So what is the centripetal acceleration? It is the acceleration that is pointed to the center, or its directions always same to the center. This notes that means the direction of the average speed and the acceleration in the same direction but in parallel. So the acceleration is pointed to inside, and the acceleration pointed inside or to the center of the circle, it calls centripetal acceleration, or sometimes in some references it called radial acceleration, with the same meaning. So that means the acceleration, centripetal or radial acceleration, it is with the same meaning. التسارع المركزي أو التسارع القطري كلهم بنفس المعنى، هو التسارع الذي يشير دائما إلى المركز، ودائما يكون التسارع المركزي عمودي مع السرعة. فلاحظ هذا التسارع المركزي لهذه النقطة، إذن هو عمودي عليها. التسارع المركزي لهذه النقطة فهو عمودي عليها. التسارع المركزي لهذه النقطة. ماذا يساوي التسارع من المحاضرة السابقة؟ What is the acceleration equal to? We know it. It's equal to A is equal to V squared divided by R. So it depends in R. When it's in radial, so it radial per second. It depends on R. ويعتمد على قيمة الآر إذا كانت بالراديان أو كانت بالمتر أو كانت بأي وحدة أخرى من وحدات القياس التي سوف نتعرف عليها. Okay, so now the important things, and I bring for you many converter to convert from unit to the other unit. So if you want to convert from radians to degree, so put the value that you want to convert it in radians, multiply it by 180 degree divided by radian, and put any examples. Put, for example, 6 by over 6 or any number, and try to solve it. To convert from degree to radians, what you can see only the change. I flip this up and this down. Just this, flip it down, this, flip it up. Numerator and denominator, you can flip it. In another references, pi in radians, he discussed about how to change. So I know pi means 180. Pi in radians, how much in x? So from this equation, I can find the degree from this equation. Theta in radius, same here. Multiply 180 as degree divided by pi, same. Number 2, 1 radius, and you can check it in your calculator. 1 radius is equal to 57.29 degree. So how much the degree in when I give it in radius? So just put the radius that you want to convert it and multiply it with the 1 radius equivalent. That is another way. The last way, 100 is equal to pi. That is to convert to degree. If you want to convert it to radius, so 1 pi is equal to 180. Degree, how much x in radius? Just convert this numerator to denominator and denominator to numerator and start your work. So that is the important things in this lecture. I hope all of you learn some information. Next lecture in Sunday, inshallah, I try to give some practice problem, one practice problem, and I try to go fast to chapter 5. And we discussed also about the exam 3 and assignment 3, and we want to finish before 20 of Ramadan to give you all the result, all the things, and you know your marks to try to collect more marks inshallah in this semester. Thanks a lot, and I'm sorry for late, and I hope all of you fine inshallah. Okay.